Okay. Hi everybody, Chicken here, and today is Saturday, and it's raining, and I have nothing to do today until later when I'm going to go and build a duct tape boat for physics class, but I decided to record a vlog because I have a surprising amount of energy for today. So, anyways, speaking of physics class, last Thursday, like 2 days ago, I was on my way to the library in my school because I had to print something off for physics, so I started thinking about something, because we were talking about different things in physics. We often have all sorts of discussions for fun, just to talk about shit. I started thinking just basic things I know about kinematics and transferal of energy, and what I know about forces, and comparing that to what scientists don't know about dark energy. What I think dark energy might be, I'll explain in this video. So, with the thing about dark energy is we know that the universe is expanding, alright? We've known that for a long-ass time. But what scientists were thinking was that gravity would start pulling the universe back together. And the force of gravity, we know, gets weaker the further apart things are. The equation for gravity, the force of gravity is gmm over r squared, meaning g, the gravitational field constant, times m, capital M, the mass of the initial planet, the initial mass that you're calculating from, and m, lowercase, the mass of the thing being attracted to the initial gravitational volume, or not gravitational volume, the initial gravitational body, over r squared, meaning it decays exponentially as the radius grows. So the smaller the radius is, the less is being divided from the top, meaning the larger value you have, the greater field strength you will have. Not the greater field strength, the greater force of attraction between the two objects. So, as two gravitational objects are farther apart, they grow much, much weaker. And you can calculate this with anything. You can take the mass of the sun, distance between the sun and the earth in meters, which would be e to the 10 or something meters, because it's a really, really long-ass distance, and the mass of the earth, and you could calculate approximately, because the earth's distance from the sun does change, because our orbit is not perfectly circular, you could calculate how strongly the earth gravitates towards the sun. Or vice versa, you can calculate the strength of the sun's gravitation towards the earth, which is not nearly as high. So what would happen, so with dark energy is what I'm thinking, what we do for our planet, when we have a force, when we measure our mass is the distortion effect of a body of matter upon space-time. Space-time being the fabric of everything in the universe, alright? And if there is matter within it, the matter will push down on this fabric, creating a distortion around it. And that distortion, how that matter affects space-time, that is the mass. And mass is absolute throughout the universe. No matter where you are, your mass stays the same. But weight is different because weight is dependent on what you're standing on and where you're moving relative to the nearest significant gravitational body, meaning the Earth in our case. So when we're standing on the Earth, on the ground, all of the forces of all of the particles of dirt and rock and metals in the planet, as they're pushing up to resist us pushing down with our mass, all of that force pushing up against our feet is what scientists call the normal force. And what the normal force is it's a net force. There is no actual normal force, but it's a combined and net vector between all of the forces of all of these things pushing against each other. Now, if the normal force were greater than the gravitational force pulling us down, we would be pushed up simply by all of the things below us. If the gravitational force was greater than the normal force, we would sink into the ground, kind of like with quicksand. We would just sink straight into the earth. So, if they're equal, we just sit upon the surface of the ground. Now, what I'm thinking of is this dark energy throughout the universe, which is pushing our universe apart at an ever accelerating rate, is what is happening is that stays the same. But gravity between any two objects, say it's between the Milky Way and the Andromeda galaxies, they're growing faster, they're growing apart farther as like a faster and faster rate. And what I think that is because the gravity between the two objects gets weaker and weaker as they push apart. And we know that's true. But what is in between them, scientists claim to not know. I think I have an idea for that. What it actually is because we know that all matter, all particles in the universe come out of fields of energy. These fields of energy create different particles depending on what they are. There's fields that create fermions, gluons, and bosons, etc. There's to create quarks, to create just all sorts of different things. And all of these little particles combine together to make the bigger particles, which then combine to make molecules, which make us. So, if all of these things, all of these fields pushing up against each other, if they push together enough, that energy creates a certain particle, alright? Because we know that matter is really just an extremely condensed form of energy. So, if matter is basically energy condensed, and we know that if you apply enough pressure to a fluid, or to a, in this case, field of energy, it will create a more condensed state of matter, a more condensed state of stuff. So if you take a field that creates fermions, okay, it condenses and condenses and condenses because everything else is pushing against it. The gravity of stuff around it is holding it together. Eventually, all that will condense, create some little particles here and there. But if everything is pushing out against each other, at some point or another, it's going to push out against stellar masses, against stars and planets and galaxies and black holes and everything. And if the gravitational force pulling between any two objects is weak enough, and the force between these two objects, just from all of the energy fields pushing against each other, is stronger, it stays constant relative to the amount of energy, then these two gravitational bodies would push apart, and space-time wouldn't warp around that. Everything's just pushing outward, just because the gravitational strength isn't strong enough to hold these things together. And so when scientists say that dark energy is eventually going to rip individual atoms apart from each other, I don't think that's true, because if you take two atoms close enough together, the gravitational strength is going to be stronger than any energy pushing between them. So those atoms will stay together. Our planet, our solar system, probably even our galaxy will be fine. But other celestial bodies outside of our galaxy, possibly even our local group, will never reach us. Light from them will just infinitely grow farther and farther away. It'll grow redder and redder and redder, and we will never see it. So when two gravitational bodies are close enough together, they're strong enough to hold against the normal force between them. This net expansion, this net push of everything, all these energy fields colliding together. And since that would stay constant, that wouldn't change. The actual strength of the energy fields is not growing any stronger. The force of the gravity is not growing any weaker. It's the exact same, but the gravitational bodies are getting pushed apart, and the strength of the field in that area is not going to be as strong, meaning it's going to be pushed farther by the same amount of energy. It's like if you have two magnets next to each other. The closer they are together, the stronger the force of attraction will be. You pull them apart, the easier it is to keep them apart. But if they're touching, chances are it's going to be pretty fucking hard for you to pull them apart, because they're right fucking next to each other. So the field strength is going to be the strongest at that point. The force of attraction. You pull them apart, the force of attraction is going to be much weaker because of the distance within the field they are. If you take something an infinite distance from the Earth, at the edge of the visible universe, the attraction towards our planet is going... The potential energy to move towards our planet is insane, but the attraction towards our planet is basically nothing. Because there's no kinetic energy, an infinite potential energy. So I don't know if that made sense to you guys, but it makes sense to me, and this is just basic physics adding up together. I'm in physics 12, and I just took basic mathematical physical facts that we know are true. We can mathematically prove all of these things. And I'm just combining these ideas together to come up with this theory. And I don't know if people have come up with this before me. Someone probably has. I'm just saying what I think. So, yeah, I hope you guys enjoyed this little nerdy rant about physics. And I'll see you in the next video you choose to watch.